Buonanotte. Goedenavond. Good evening. Welcome to the University of Aruba. My name is Erik Meijts. If you wouldn't know my name, just being polite and introducing myself, but I'm going to introduce a couple of people to you tonight within the framework of the talk that we're going to have by Patrick Boyden. Dr. Patrick Boyden is sitting over here and is going to talk with you about Aruba and corals, a love story lasting thousands of years. And I'm going to frame for you a little bit why they are here, because it's a group of people that are here. It's actually 6 people, and soon 3 people will be on stage, 4 people will be on stage answering questions and having a discussion about this. But I first want to frame this in the agenda of what the University of Aruba is doing at this moment. As you know, we've started the Sustainable Island Solutions through Science, Technology, Engineering, and Mathematics program at the university. And as part of the research offering of those programs, we are, of course, looking into the main asset, or one of the main assets of what Aruba has, and that is the ocean. And people don't know a lot about what we're doing over here. So I wanted to let you know that what we're actually doing at this moment. We have one project going on the connectivity of coral reefs between Bonaire, Curaçao, and Aruba. That's with Professor Philip Volkaert from the KU Leuven and Violeta Marquez Lopez, who is working with us as a postdoc with the support of Tobia de Cicelo and Tatiana Becker and Oriana Wouters, by the way, who are supporting in the diving for the tissue sampling. That's one project. The second project is what we're doing with Karmabi, our sister island, where we're developing an honors program to make more people actually engage in leading research into our marine environment. Recently, we started working together with researchers from the Max Planck Institute in Mainz, looking at the oceanographic characteristics of the waters surrounding us. And we are involved in the InReef projects with Wageningen University, with Professor Lisa Becking. And we're also currently involved together with Fondation Parc National Arie Koch, Scubble Bubbles Foundation, and Wageningen University in the Turning the Tide project, setting up a program to develop artificial reefs around Aruba, and especially teaching students also to monitor those artificial reefs. That's not all, because we're also setting up currently a project surrounding nature-based solutions, which is part of the Dutch science agenda. Soon we'll know more about that. And we collaborate with our own metabolic foundation in the Surfside Science program. Just to tell you, there's a lot going on, all about what the ocean is for us and what we understand of the ocean, because apparently we humans have a difficult time seeing through that silver mirror of the surface of the ocean. Okay, that's my research, of course. Within that framework, you meet more and more people, and a very interesting research team came to look for us and reached out, and it's led by Patrick Boyden, who is the principal investigator, who together with Professor Alessio Rovere and Giovanni Scicchitano present a research collaboration that spans from the University of Bremen, the University of Venice, to the University of Bari. That's in Italy. And then they come to the Caribbean to study coral reefs. And why do they do that? And how do they do that? And I was totally fascinated. And then they started talking to me about it, took me underwater, made me see under the surface what they are doing. And Malena, thank you also for having me there, because it's a very fascinating project that actually taps into present day coral reef development in times of climate change, and way back 125,000 years ago, what happened then. And one thing that I already learned through this project is that in Aruba, we have the most pristine coral fossils that you can imagine. And it can help us understand the present, the past, and the future of what is going to happen with our coral reefs. This presentation is being recorded, just so you know. The camera is not focusing on you, but on Patrick Boyden. And I wish you a lot of fun listening to Patrick Boyden and his love story lasting thousands of years about Aruba and corals. You're welcome.
Good evening, everyone. Thanks for showing up. I'm really excited to share with you some of our most recent findings about the project that we're we're conducting here on the ABC Islands. I'm going to start, of course, with making sure that, sorry, 1 second, there we go. I recognize my project sponsors because they're the ones that make it all possible. Mainly the German Science Foundation is the chief sponsor of this project, with the ERC, the European Research Council, also providing a significant portion, and the University of Bari as well. I have to start, of course, talking about climate change. It is the negative aspect of our existence here on Earth. And we always have to pay attention to the fact that we're always going to have now in the future a warmer world for future generations. This is a graph of global average surface temperatures spanning from the 1800s. So right about the start of the industrial period. And you can see that global average surface temperatures have just skyrocketed over the last couple of decades. This is a trend, again, that we see around the world, and not just here in Aruba, not just in Germany, not just in Venice, but in the Arctic as well. Now, of course, there are natural drivers of climate change. There's the way that the Earth orbits around the sun. There's the way that the Earth wobbles. And there's also the change in the way that the Earth is angled at the sun that changes the amount of solar radiation, the heat that we get from the sun on the planet. And these cycles coincide with one another to produce what we probably know as ice ages. Now, one of the things that we focus on is not the ice age aspect, but rather the inter-ice age or the interglacial periods. Of course, there's also the elephant in the room, the non-natural drivers of climate change, right? Our production of CO2 in the atmosphere, our production of methane, our contributions to it cannot be avoided and have to be addressed as soon as possible. This global climate change that we're experiencing coincides with driving sea level rise that we experience not only here in Aruba, in the Netherlands, in Germany, in the US, around the world, but the sea level itself is driven by several factors. One is the way that the Earth's crust moves. So the surface of the Earth is dynamic. It's not a solid. Over geological time, it will move. There are ways that as temperature enters into the ocean, it actually expands. It causes the molecules in the ocean to expand. This is thermosteric changes in sea level. And then there's ways that the land surface actually elevates due to tectonics. So as the Earth's plates move with one another. And of course, there's also sediment compaction, which is driven by human development, aquifer extraction, so freshwater extraction from those aquifers. This land will start to settle and sink. So all this drives the relative position of sea level to us higher usually, and in some special cases it actually drops, but that's not the case here in the Caribbean. So the main contributors to sea level rise, though, are the ice caps, and we have to now in our period on the Earth, we have Greenland and Antarctica are the two main reservoirs of fresh water on the planet. And over the last since the 2000s, there's been catastrophic loss of ice mass, especially on Greenland. Now, this mass loss is not just happening now because in the last couple of years, but rather it's a cycle that goes up and down over time. But it's been exacerbated by human activity. And we know this because we have geological records that go back into the 65, 70 million years that indicate that sea levels have fluctuated significantly. And this is due in large part not only because of changes in temperature, but also in changes of landmass orientation. In the recent history, We have, of course, our our COP21 targets for trying to keep the global temperature below 2 degrees Celsius. And what we can see when we look back in time in the geological history, we can see other periods of Earth's history that have also experienced similar increases in global temperature, and also therefore increases in global sea level. One of the further back periods is the mid-Pliocene, which represents 4 million, 3 million years ago. This is, again, putting in context for everyone when Lucy was first starting to walk. This is a period in Earth's history when Earth's temperature was around 2 to 3 degrees warmer than pre-industrial, and the CO2 in the atmosphere is around 400 parts per million. More recently, at least for us, is the last interglacial. So this is the last warm period that the Earth experienced, and this was plus 1 to 2 degrees warmer, with CO2 actually below what we have today at 300 parts per million. So it's just to keep in mind that throughout Earth's history, there have been fluctuations in global climate and sea level. And we're really interested in now looking at the last interglacial. How is that dynamic affected? So during the last interglacial, we know by geological proxies that Greenland was significantly melted. So we're talking two-thirds of the overall ice shelf in Greenland gone, and about a fifth, just over a fifth of Antarctica was most likely melted, if not more. There's still debate in the actual overall contribution of Antarctica during the last interglacial. Now, of course, we always have to think back to Victor Hugo and his quote that the future is a door and the past is the key. This really drives our research, because what we can do as geoscientists is that we can look back in this record and we can start to piece together the puzzle of how the world has functioned before and set a baseline to understand better how it will function in the future, and to gauge our impact on future climate change and future dynamics in the Earth system. So first, we have the coral reefs. Sorry about that. We have the coral reefs. We're looking at the modern coral reefs of Aruba. Now, the modern coral reefs are, there should be a video. It's my computer's freaking out, sorry. So we look through scuba diving, we start looking at how the reefs function in the modern. I think there's a compression issue. Anyways, so we have spectacular coral reefs on Aruba. That's not up for debate. But what we want to see and what we look for in our research is trying to get an overall picture of the health of coral reef systems and how they respond to climate change. So one of the aspects that, one of the means in which we collect our data is to conduct underwater surveying, utilizing GoPros and photogrammetry techniques. These photogrammetry techniques are basically stitching together a bunch of photos. We're talking 700, 1,000 photos, and then using algorithms to create a digital elevation model and a digital mesh of the outcrop or of the reef environment to bring back and analyze further in the lab. This expedites traditional ecological surveying methods by easily capturing a significant swath or a significant area of each reef environment. I do apologize. There's supposed to be a bunch of videos that are really nice on here, but apparently they're not working. We also focus on trying to gather close up reef traits Each coral species has their own unique way of growing, each unique way of polyp size. So the little actual organisms in the overall community of a single coral have their own unique traits. And so what we look to do with our research is we also look to categorize and evaluate each individual polyp through close-up analysis. We also have, and now it's working. We also have the ability to produce then these 3D reef models. This is in Baby Beach. It's an early rendition from our processing that we did here over the last couple of days. And you can see that we have captured the rugosity is what we use in reef ecology terms, but the bumpiness of the reef, for example, this plays a quintessential role into how the reef itself can dissipate wave energy, for example. We can also reproduce 3D models of individual corals. This allows us to look at the overall volume more accurately of each coral colony. The rugosity, again, each coral colony, the way it's shaped plays a different role in how the coral itself can either respond to change or represent the way in which it lives in a different hydrodynamic environment, so the different wave environment. From the modern, we fly back into the paleo environment. Again, the video is not working, unfortunately, but we utilize the same methodology, but on land. What's really beautiful, here we go. It's buffering. That's, maybe now it will. No, yeah. What's really beautiful about Aruba is that the last interglacial, the last warm period that I mentioned earlier, is preserved in the first reef terrace around the island. So whenever you're driving around, whenever you're hiking around, snorkeling, whatever, the first terrace that you see just above the water is the last interglacial. Here we go. So you can actually go across what was once ocean and see these beautiful reef sequences. So frozen, really frozen in time. And this is just a reminder of how these terraces are formed from a geological perspective. Reefs themselves always try to follow sea level as it goes up and down throughout geological history. There's different ways in which they can respond. If sea level goes too fast, they drown, they give up, they can no longer live in that depth window. If there is a jump, but it's not too great, this reef sequence actually moves further inland. If sea level stabilizes at a relatively shallow window, then the reef itself will continue to grow up vertically in a catch-up formation. And as sea level slowly rises, the reef sequence will keep up and will continue to increase in thickness over time. Now, when sea level stays stable, the reef sequence grows further offshore in what we call progration. And of course, when sea level drops, the reef emerges from the water, the corals can no longer live, and the reef dies, and the reef starts growing further down in the basin. Now, to complicate matters, the Earth's surface, as I mentioned, is not stable. It fluctuates, it moves. And so you'll have different sequences around the world based on the geological setting there. So you can have an uplifting reef, uplifting coastline, where each terrace is preserved as the coastline elevates. You can have a stable coastline, which is similar to what we see here in Aruba, where the terraces will start to build with one another and make a very complicated geological history to unravel. You can have a subsiding that's gradually subsiding, and there the terraces themselves will slowly disappear beneath the waves. And you can have a significantly subsiding coastline where the terraces drop far offshore relatively quickly. To walk through this process, I think it's very poignant if we go to outcrops here on Aruba and start looking at what they look like and what we see as geologists when we approach these unique and very special, I have to emphasize, very special resources on Aruba. So this is an initiation of reef growth. Here we see the basement rock, the Cretaceous, so the very old basement that Aruba has, the mountain ranges, right? This is from the Cretaceous period. And we can see here that the reef has started to colonize this as sea level's risen, right? And we can actually dive in and look and see this brain coral growing directly on the basement itself. So this is a really cool opportunity because it allows us to understand and pinpoint a time at which sea level was there. We can then move further and another video. And we can start seeing when sea levels really inundates the entire land. And so here, Alessio is standing on a massive brain coral. We're talking close to 2 meters in diameter. And this is at the uppermost end of this period where sea level rised up, and the reef really started to keep up with sea level. That's a little jumpy. Oh, we can also see when sea level falls. So here we have a bed of elkhorn, massive elkhorn. And when I say massive, I mean the branches themselves are massive. These massive elkhorn coral cobbles or rubble has been strewn across the reef as sea level falls. So as wave energy increases, the reef itself is broken up, destroyed, and each individual piece falls in place and gets cemented over time. And in fact, you see this overtopping beautiful, massive colonies of columnar coral that are called Orbicilla annularis. Sorry, I'd have to throw that in there because this is just phenomenal. I mean, these specimens are sitting right there in your backyard. And so everyone has the opportunity to go to these bocas and see for themselves the unique history that Aruba has when it comes to the last interglacial. We can also see that close up. This is another brain coral that's sitting on top of the terrace at the very outer edge in what we would consider the last remnants of reef growth. It's most likely actually a piece of rubble. So it was ripped up as it was growing. But this represents, again, this regression. So as sea level left the terrace. We also gather, in order to gather this data, we survey each boca utilizing similar methodologies that we do underwater. I apologize again. Oh, there we go. Sort of jumps around. And so we spend days and days and days in these beautiful places. I do admit we have a pretty great job. Taking close-up photos, taking high precision GPS points, and making large-scale photogrammetry projects of each boca. So while we're while we're working on taking photogrammetry, we walk really slowly. We capture, again, 700,000 photos easily with regular consumer grade cameras. And this is of each outcrop or each boca that we find. We also go down to the similar trait level that we focused on in the modern reef. Again, this is looking at the coral polyps, the little guys, how they respond, right? So were they different during the last interglacial? Were they, did they have a different size? Did they have a different form? Sorry. Another way that we can look at this is actually utilizing models. So here we have a model output that's a relatively simple 2D model where the reefs following a succession of interglacials since 400,000 years ago have developed a reef system on this sample coastline. The diagonal line is the coastline here. And so we can test hypotheses on, well, what do we think happened, right? So we can look at different scenarios. We can say, okay, uplift rate was 0.05 millimeters per year, for example. We can change other aspects of it to produce even further different geometries, just to test to make sure that what we have observed has a realistic outcome. What we can also do is produce then these fantastic 3D replications of each outcrop. This is from Curacao. This is Boca Cortaline. It's about 200 meters in length and was captured by a drone. Each one of these digital outcrops provides us with great insight when going back to the lab, because we can look at different geometries within the outcrop to ascertain the different relationships between coral communities, between sedimentary environments, so beaches, etc. But this all is a moot point if we don't think about what the impacts of reef stability has on Aruba's coastlines. And that sort of is the main transition into talking about extreme events on the coasts, specifically hurricanes and tsunamis. Now, as a brief refresher, hurricanes themselves are low pressure systems with a high an eye and branching out squalls that rotate. But as this storm system moves across the ocean, it builds up the sea surface to create a storm surge. In conjunction with that storm surge, there's a significantly higher increase in wave energy and destructive power. When we think about that destruction, we obviously always think about wind, right? Hurricane force winds. The storm surge plays a quintessential role in how destructive hurricanes can be. And of course, the waves themselves produce significant amounts of erosion on sandy coastlines. Hurricanes themselves, we can track them for the most part since observations began. This is, for example, all of the hurricanes since the 1800s in the Atlantic basin. And we can even zoom in and look at, okay, what hurricanes were here over the last 200 years. We can also consider tsunamis as significant extreme events on the coastlines. This is, of course, the 2011 tsunami in Japan that created significant damage. And tsunamis themselves happen when there's displacement on the ocean floor. So when a mass moves on the ocean floor, the water will be moved out of the way, creating this massive wave that can cause significant damage. Now, while I mentioned that we have this wonderful record since observations began, we also have a wonderful record here in Aruba, especially of historical events that are recorded in the geological record. And these are recorded by boulders on the coastlines themselves. So boulders on the ABC Islands, you're thinking, okay, this guy's now talking about tsunamis and hurricanes from rocks. How can that be? But what's really cool is that because of the unique geometry of the Aruban coastline, you have boulders that have been broken off from the last interglacial, usually the last interglacial coast, and have been uplifted and thrown on the coast itself. So there have been previous studies that have also looked at this. One study suggesting that there was 3 main events in 500, 1500, and 3000 years before present on Aruba specifically. There's another study that's suggesting that they're all tsunamis, right? So there's a lot of disagreement in the scientific community what these historical events could be. But what we're trying to do here is we're trying to take the same methodology again that we're using in the modern and paleo reef by taking these photogrammetry projects. We can look at the overall coastal geometry. We can measure the storm ridge. So on the bottom left-hand corner, storm waves will usually push up a mound of debris. This mound of debris will be left in a long ridge and is indicative or indicates a storm event. And these big boulders, we can actually look at the volume and the energy needed to move them. And then from that, we can deduce whether or not they were a tsunami origin or a hurricane origin. So through the same methodology that we use, we can calculate these specific forms and really go deep in the lab and test these hypotheses. I want to thank everyone for joining us today. I apologize for the videos not working, but I really appreciate that you guys came out, and I hope that we can have a fruitful discussion following this. And I hope that everyone takes some time in the coming days, coming weeks, to go see the fossil reefs that are here on Aruba, because they are spectacular. Thank you.
Yes, I think now is a good moment to invite Professores Scicchitano, Rovere, and Siske van der Waal on stage, as well as Patrick. But can you take those chairs one down, because it's a little bit like too much over there. So if you come forward. Yes, break down the ivory tower. And the whole idea of this team was also to get input and also discuss what the impact of their research is and what value it can have for the Aruban community. I know that Siske wanted to say something too. I'm first going to hand the microphone to her, and then please, any questions, thoughts, ideas, critical notes, things you want to ask now, because they're leaving tomorrow, right? And they're only coming back next year, so this is the moment to ask what you want. Siske is staying with us.
All right, good evening. Thank you, Patrick, for this wonderful presentation. And I hope you all noticed as well during the presentation, there are some events described that they can see in the past that we can think of. It happened recently, more recently in our waters, hurricane events that wash up those ridges of dead coral that we've seen happen. So it's really interesting to see that that has happened in the past, and it will continue to happen as well. It only may be happening at a much faster pace than we're used to, or that would happen in the past. So it's also what can also be measured by this is how the Anthropocene, so our human impacts, are basically moving time faster or moving these processes faster. So that makes this really interesting. Additionally, they're using a lot of very interesting methodology, very practical equipment, very simple equipment that can also be applied for research, for FP&A, for the University of Aruba, for our science parts and projects that we intend to apply. And a lot of things that are very interesting at one point is that the acroporas, the elkhorn coral, is usually the base in the past history as well, which ties in with the Turning the Tide project, where we're actually going to be using these species to kickstart the artificial reefs. So that's in line with the succession process of corals that are demonstrated here as well.
Yeah, and I can confirm the observation about the low threshold research equipment for the 3D rendering, where the key ingredients were a broomstick, a couple of tie wraps, and 2 GoPros. But think of it on the other hand, on the other side is, of course, the data setup to process that. And that's quite a complex one, of course, and that takes a lot of rendering space and time. I have a ton of questions, but I'm sure that you also do have ideas, things you want to know. Don't rely on me for the questions, please. Yep.
Where exactly did all this study took place? North coast of Aruba, East Coast, West Coast?
Thank you for the question. So we really tried to make a comprehensive tour of the entire island. So what we ended up doing is mapping this last interglacial terrace around the entire coastline. So we went behind the hotels, for example. There's still some that's luckily still preserved, despite the hotel's best efforts. And of course, on the windward side is probably the more spectacular exposures of this. You'll see what's really interesting is that there's different phases of reef development that are preserved depending on where you are. That's mainly driven by the way that the ocean erodes the coastline. So on the windward coast, for example, you'll really see these really tall successions. And that's because the front part of the terrace is now gone. And so now we see basically the very the very highest bit, rather than by Malamok Beach, for example. The terrace there is also last interglacial. It's at a different elevation, but it's the distal part, the furthest, the lowest part. And because there's lower wave energy there, it's been preserved over time. So we really try to look everywhere possible for this to see if there's any spatial difference between outcrops.
Thank you for your very unique presentation. Having lived in Cayman Brac for 4 years and done a lot of diving, I was wondering if there was any significant difference in the formation of the coral reefs between the interglacier and the ice ages. And if so, is any particular variety of coral more resilient to hurricanes and to tsunamis? And if so, how should we then be looking at planting those? I come from the tourist area, so I have to protect the tourists as well.
Sure. Yeah. Thanks for the question. Yeah. Of course, there are different coral species that are more resilient to high wave energy. Think about brain corals, for example, or more massive forming corals. Elkhorn corals are more delicate because they have greater surface area, so they tend to be displaced. But the point being, I think that's maybe the next step in this discussion, is that Elkhorn corals are faster growing than brain corals. And if you start a reef project with brain corals, for example, the takeoff rate is relatively small, and you have a good chance of not having successful colonization of the corals. Whereas with the elk corals, and this is what we see again in the initiation of the last interglacial period, is that the Elkhorn corals come in, they propagate, they're really happy, and then the slow growers start showing up and start taking over the reef in the end. I hope that answers your question a little bit.
The dubious pleasure of living through a hurricane in the Caymans and having seen the reefs before and afterwards, Elkhorn's massive damage, the brain corals were still there. But then when you look at the encouragement to keep on planting, people want to see immediate results. And the brain corals are not going to give you that one. But thank you for your presentation. And yes, it did answer the question.
Alessio, you want to say something?
No, yeah, I just wanted to add that, yes, it's also part of, in healthy reefs, it's also part of a natural cycle when you actually have Elkhorn corals growing up and then a hurricane comes through. We see that a lot, for example, in the Bahamas, but also on the Mexican coast. Then you have die-offs and new substrate is created for the regrowth of new Elkhorn corals if the reef is healthy and happy. And instead, if the reef is not healthy and happy, then we have a problem because the Elkhorn corals cannot restart, and you only see the dead corals. So, yeah.
So tapping into the fact that you just mentioned the Bahamas, when we went diving together, you told me that the fossil corals in Aruba are actually of spectacular quality. That's what you said at that moment. Now you've had a deeper look into it. And can you explain what you meant by that and whether you still think so?
Well, yeah. Okay. So I must say that I was quite lucky during my early career. I could move around the world quite a bit looking for fossil corals of this age. And well, in the Bahamas, there are certainly spots where the coral reefs are well preserved, but there is also a lot of sediment in the system. So they're usually, the fossil corals are intertwined with lots of sands, like beach sands, dune sands coming on top of them. Here instead, we really see the entire succession of the reef, as Patrick was describing, starting from the grow up of the first Elkhorn and then going up and then the die off at the very end, which is something I have seen. I mean, I fell in love with this morphology in Bonaire in 2016 for the first time. And this is why I kept coming back in Curacao then twice, and now here in Aruba for the first time, but there's going to be others times for sure. And I must say that, well, yeah, what I told you on the boat is that probably so well preserved in terms of preservation, in terms of how clear the fossil record is, how good of a story it's telling to a geologist when you observe the stratigraphy. I have seen something like this probably in Aldabra, which is in the middle of the Pacific Ocean. It's a UNESCO World Heritage Site, but few other sites. In Mexico, I have seen the reefs in Mexico, which for us are really famous because they've been published in Nature. So it's very famous for us. And they're not as spectacular in Yucatan. So they're not as well preserved. I mean, it's not a competition, but
No, but we have John Wardlaw here, who has been the dean for the Faculty for Tourism Management Studies for 12 years. Yeah, quite a while. Patrick Melchior from the Aruba Tourism Authority. And I'm really thinking like this could be a spectacular thing for the national parks to really tell the story of our corals in a different way. But also use that as a means to preserve them, that knowledge, because that's also important. But I don't know whether Siska, you want to say something about that, but it's just an idea that came to my mind in the past months.
Well, it's actually during this project and in joining them in the field a few times as well, it's basically those barrancas that we from a child are so used to seeing. So we kind of take them for granted. We think, wow, that's normal. It's everywhere. It's not everywhere. So it's something we can be very proud of. And it's something we should preserve. So do not take it for granted. Do not drive over it. Because it should be preserved. It's something we can cherish and be very, very proud of. I actually, if there's no other questions, I want to ask a question myself, if that's possible.
Go ahead, and then there are some other questions, and I see 4 hands already, but go ahead. So 5 questions.
We're currently in Aruba facing a massive disease, the stony coral tissue loss disease, which is confronting a lot of boulder corals, brain corals especially. Can you see traces of such mass disease events in these fossil histories?
That would be a science paper, yes. No, I think the the tough thing in the fossil is that you can make hypotheses about what happened, but you can definitely see in a lot of the fossils on the island, you can see die-off horizons. So levels of the coral that had died off were recolonized and therefore preserved. But the problem, I think, is that there's no way that I know of, at least, to test to see, is this due to sudden coral tissue loss, or is it bleaching, for example? Because that's another threat to coral reefs, right? That's happening all around the world. Or is it just another disease, or plainly that the coral itself could no longer live? So I think if you dive in the modern reef, you'll see patches on corals that have died, and then the coral itself is starting to come back, and we see that again in the fossil reef. But beyond saying the coral died and came back in that area, unfortunately, we have to develop new methodologies to test for that.
Scicchitano is just asking you to develop the field of clinical paleontology.
Hi, everyone. Patrick Malgers, Aruba Tourism Authority, the evil side of everything. Obviously, we're in a luxury position in Aruba when you look at it commercially. High demand, a lot of people wanting to come, but obviously that has its impact on nature and on everything that is called preservation. We're in different committees trying to mitigate that human impact from all kinds of angles. And I was wondering whether you would have specific recommendations coming out of your studies, this research, that you would be able to share with us. How do we move on from here?
Well, that's okay. We're a bunch of geologists, so probably not the best to answer these questions, especially when it correlates to the ecology of the modern reef, right? So probably Scicchitano will have a few words to say. But I think for the fossil reefs, I can testify of one thing. I come from Italy, in a place where the fossil record has basically disappeared because we constructed on it everywhere. And now we are scraping into caves to try and find the records that you're so fortunate to have here well evident. So one thing from the geological heritage point of view would be to try and preserve as much as possible. And if construction must happen, document as much as possible for the future generations what was there, because we don't take for granted that it's going to be there forever. And it's not infinite as well. So the windward side is probably less appealing for development. But one thing we have observed here is that, of course, the leeward coast is much more developed than, for example, in Curacao. Correct me if I'm wrong. And in Curacao, we still see pristine sites where we can tell what was the difference between the windward and the leeward side back then. Instead, here, I have the feeling that it's going to be much more difficult because a lot of it is gone. Yes, patches are preserved, but when we see patches, we are really scraping the end of the barrel from the geological point of view because we do not have the context. So that would be one thing to keep in mind. And sustainable tourism, and then I leave to Scicchitano, to me, also means doing something to preserve the non-living heritage. So the geological heritage, the archaeological heritage, of course, which must be put together with the ecological, because we learn things from one another. And if you miss one part, then you cannot talk to your colleagues.
So in addition to that, the geological heritage being very important. So inside all the protected areas that FP&A manages, the geology is protected as well. But outside of the protected areas, it's not. So that's something where we all have to play a role in protecting it. and also make careful considerations. Everyone wants to develop on the coastline, but that is exactly these areas where this geology is still so present and visible. So it's definitely things to consider in how to develop our island further, if we want to develop our island further. So when we, how to preserve this best. It's very interesting to keep this preserved as well, because we keep getting new questions arise, and then we can look in the past, what has happened then, learn from the past, as that is the door to the future, as you mentioned in your slides. And one thing that becomes very clear also from this structure that is so well preserved is that even if we as humans may not survive all the changes that are happening because they're happening so fast, in the end, corals likely will survive. Maybe not the same species that we have now, but they will survive.
Okay. There's a next question.
Hi guys, I'm a student here, but I'm a student of law, so I know a little bit of nature. I'm interested into the sustainability and now obviously from the island as well. So I've seen a lot of the sites you guys have seen with other eyes. Like Sisa said, we live here, we take it for granted, but it's our backyard. So, and on the other hand, we get to see it every day if we want to. The same thing with the beaches. Not everybody goes to the beach all the time, but when you go, you appreciate it. My question was a bit more on the scientific side, because you guys talked a bit about temperature rise, or first CO2, then temperature rise, then water level rise, and then you talk about corals. But then you also have, like Sitka mentioned, the diseases that corals might face. But the CO2 already brings the acidification. The CO2 brings the temperature rise, and that's another factor on its own that affects the water, but it might affect the coral directly as well. So that's my question is more about how do these other variables affect the coral, not just the water level rise, but also directly the acidification and the temperature.
Yeah, thank you. So I had mentioned when discussing seeing the sudden coral tissue loss disease in the fossil record, that corals also face bleaching. So this is one of the main stressors that the world's coral reefs are facing right now, is this massive die-off where the reef itself just no longer exists. It's now a fossil record. And this is driven because of ocean acidification, because of sea surface temperature increases. And in terms of seeing that in the fossil record, I think that we have, right now, at least, we can see that the 1 to 2 degrees was good for the coral reefs in the past, in the last interglacial. But again, the PCO2 in the atmosphere was 170 less than it is right now. And that number is not dropping, right? So I think when looking at the past, it's an effective way to understand what the natural system would look like and what massive perturbation, so a massive change in either temperature or CO2 or both could do to the system. And we really have to not only pay attention to sudden coral tissue loss, but also bleaching. That's not to downgrade the alarm that sudden coral tissue loss rings, because again, any additional stressor could be the end of coral reefs on Aruba as we know it. And I think there was a lot of dive sites. I was on the land team, so the divers maybe can attest to this, but there are a lot of sites that were reported in literature from the 80s that are just not there anymore. So I think that's telling as well in terms of the pressures that the reefs are facing now. Yeah.
Professor Rovere, you want to say something about this or no? Okay. 2 more questions here. I'll be with you in a second. Tatjana?
Yes, I wanted to ask, because I also overhear you guys saying that in Aruba we have very large size fossil corals. And comparing that maybe to other areas in the world, what do you think might be the factors that have led to these much bigger corals in the past in comparison?
Well, that's a great question. And the answer is I don't know, but I can give you, I have, that's what we are set to investigate, right? But yeah, I kind of, and this also goes into the question that was asked before. I kind of think if you look at this past world, so the past warm period, we got to the high temperature, so around 1.5 degrees Celsius globally, very slowly, in about 10,000 years. So we got there very slowly. So now we have been on this trajectory of a warm climate because we are living into an interglacial since at least 4,000 years. Okay, 4,000 years we have been living in a slightly let's say stable to very slightly warming climate. But then what changed is the speed since the Industrial Revolution, is the acceleration of how warm it was going to be. So I'm wondering if we gave these reefs another 6,000 years without impacts, without CO2 in the atmosphere, without rising sea level, maybe we would wait and see how big that they become as big as those that we observed in the past, right? But now we lost the train because we are basically accelerating everything. So we are, in ecology, you would call it shifting baselines, right? So you're jumping to another state and you do not have the original state anymore. So I'm also impressed. We found coral heads, diplorias, which were like about 3 or 4 meters in diameter, which I do not think you observe them in the modern, at least. Do you see them? I mean,
Curacao, in Curacao, you'll easily find them.
But maybe 1 or 2 I've seen in Curacao.
I've seen 2 last week, but okay, of that size. But so they're still there.
They are still there, but you find them a lot in the fossil record. And one thing we're going to do is trying to identify the density and the size of these colonies to see basically how different it was. It's another state of the climate. It was as warm, or as warm as we're going to get to, but in a different way. We're going to get there in a different way. And our way is more destructive. I think that's...
I think to answer the last part of your question about the spatial distribution around the world and of fossil records, part of it is just the preservation bias. Aruba is a very unique place because of its arid climate. The limestone is really well preserved. I did some work in Madagascar, and you find little fragments of coral and you're really excited because you found something, but the rest is crumbling. So if you think about the modern shoreline in the on the windward side, it's all this really weathered limestone that's really indiscernible. You can't really see anything in there. And that's what a lot of coral outcrops around the world look like. So here in Aruba, it's very unique in terms of the preservation that you see. Maybe the Red Sea is another area where you could find similar preservation conditions. But really here it's sort of this perfect, I don't want to say perfect storm, but perfect coming together of different factors to enable that.
All right, my question is more based on the future, because from what you guys were talking about, mostly past and present. Will the study include any models on erosion of our coastline, or perhaps bringing back certain corals in certain areas to avoid erosion of where you guys looked on the North Coast? So what models do you predict will be derived from the study for the island, or maybe there are already at FPNA?
So actually, I'm a hybrid geomorphologist and modeler. So great question. I think it's one of the very important things that we can do as a scientific community to look at and try and predict. There are a bunch of model suites, so models that already exist that can look at erosion. What I can say is that on the North Coast, you have a rocky coastline. The overall erosion is relatively small. it's a slow rate. On sandy coastlines on the leeward side of Aruba is a different story. I was talking with Harold, the archaeologist, and I keep forgetting his last name. I apologize. Harold Kelly. Yesterday, actually, we were looking at some sites, and he was mentioning that, oh yeah, and this beach during the last hurricane was completely removed, and you saw the terrace still. Because I was commenting on how the terrace disappears, and he's like, oh no, but it's there. The beach just is covering it right now, and I've seen it be uncovered. So one of the things that we can really look at is understanding the severity of hurricanes that could potentially come through. So again, that goes back to looking at the historical tracks of hurricanes, right? Understanding what's the return period of those, and then we can do morphodynamics. So these models that look at how the sediment shifts under storm conditions. And I think that my colleague, Gianfranco, is probably more the expert because he's the real modeler on the team to answer that further.
Yes, but I am. Yes, we have to consider that probably in a climate change scenario, hurricane will become stronger and more frequent. That's an important thing to take into account, because in this situation, the impact of a big storm, of an hurricane, from an erosional point of view, is very impactful on the system, and you are losing resilience in the system. So more strong hurricanes means much more erosion. So it's very complicated now to try to modeling hurricanes under a climate change scenario. There are a lot of authors are trying to do that, but it's very hard. And probably it's a line that can conduct in a some mistake, some overestimation of the system. So for now, in our opinion, is much more important to discern in the deposit we found in Aruba, which can be attributes to hurricanes and which can be attributed to tsunamis. Okay, because there is these discrepancies in the opinion of the other authors. A lot of authors say it's all of that are tsunamis. Other authors, no, all hurricane. Our feeling is that is a mix between hurricanes and tsunamis.
Okay, I think we're going to a last question and then looking at a clock because we promised you 6:30, then we're going to round off.
I'll try to keep it short, but I have a twofold question, actually. I find it very interesting in relation to the hurricanes as well, and to the current conditions of the reefs, because you're doing present and past. So in the past, you have seen this dramatic climatic events like hurricanes, tsunamis, and then you see the regrowth. And again, the colonizer, the acroporas first and everything. And we look at recent hurricanes that have happened also here in the Caribbean, even in Aruba, but we don't really see this regrowth of acropora. We still see rubbles. So like I have a twofold question. Is there any way that you can see like the difference in timeline for regrowth from the past? And if you can see, compare it to present hurricanes and regrowth events, if there is any regrowth events, and if there is anything you can link it to water quality. Also, if there is anything that can show actually like in the past, the regrowth and now no regrowth, and maybe link it to water qualities. Now, thank you. Sorry.
No need to apologize. That's a great question. I think one of the really interesting things that we see in the paleo, again, are the overall size of the colonies. And this indicates one major thing to us is that they had the conditions enabled them to grow for long periods of time. We saw a bunch of these Orbicella aneurilis colonies, the columnar colonies, I think is the common name, that are 4+ meters in diameter, which indicates that they were alive for hundreds of years, right? So in terms of a rebound following a recent event, it's really important that they have the time and conditions that allow them to reform, to rebuild, and become more robust, because small little baby corals are relatively vulnerable to be ripped away in any sort of severe storm condition. Not even a hurricane. We could just have a tropical storm and it would still, or even the normal conditions on the windward side for that matter, can be too much for fledgling corals. In terms of the return period in the fossil reef, that's one thing that we're really looking to solve through dating of the coral reefs. So that's going to be some interesting results if we see the overall age. If there's some jumps in the reef or something, maybe we can find a more precise answer. But I think if you just look at the corals themselves, you can really determine that length of time that's necessary for them to really become strong again and survive any other event.
Okay, I'm going to be naughty here and still ask one thing. When we had a discussion with Alessio on regrowth of those coral reef systems, you mentioned when we observed like a dead coral reef in front of the city harbor during the training, and you mentioned during the after talks like how long it would take in a natural way to regrow. Can you repeat that number of years for us?
Well, it was after a couple of years, if I remember correctly. So I think, so what we see in the fossil reef, it takes a few thousands of years to actually get up to another stratigraphy in the reef. And the argument there was that what we observe now when we see all these dead beds of Acropora cervicornis, we see them on the very top of the sequence, which was the very important geological event, which is the start of the Ice Age, basically when sea level dropped. And we were debating, saying, well, what nature has created in a few thousands of years, probably we have been created in 20 years or so, maybe even less, because there are reports from those sites where it was all a living coral reef and now it's all dead, basically. I was particularly saddened by that dive. So to actually see that there is no regrowth, no anything. I was looking around for small. There is small. Okay, maybe I didn't. That's two. But yeah, it's that is probably the message to take home, that it takes thousands of years to create a healthy and well-developed reef, and it might take very, very little time to actually destroy it. Or to lose it.
Okay, yes, thank you.
If I can just add to that, so this was a location we were also looking at because it's intended for the placement of artificial reef structures. So that's the intention of placing artificial reef structure, that you're actually kickstarting that structure shape of corals that would have taken thousands of years to grow. You're already placing those shapes to attract all the marine life that corals would sustain. And that marine life can then help all the corals that would grow on it in their baby phase to maintain them healthy so that they can grow and develop further. And then after some time, you don't even see the artificial structure anymore because it's fully overgrown with corals. That's the intention of artificial reefs. And that's why sites that make you sad, we do have to see the hope that is there. And there were lots of little coral recruits, we call them. They're very small. So it is a sign that new corals can grow in that area. We just hope to kickstart that a little bit with an artificial reef program.
Right.
Yeah.
Yes.
Okay, so a sad message and hope at the end of this story. I really want to thank all four of you, Siska van der Wel, Alessio, Rovere, Gio Scicchitano, and Patrick Boyden for your great contribution to thinking and developing thought and critical insights about our coral reefs. And I hope you promise to come back next year. So please do, and we look forward to a next opportunity to hear from you. And Alessio, you want to say something?
Last thing, thank you so much to all of you for welcoming us in Aruba. It was a great time. when we wrote the proposal to come here, we said we knew people in Bonaire and Curacao, and we said we're going to look for people to collaborate with in Aruba. And I think it's great. Thank you so much.
Thank you.